All righty, we're all good?
Mm-hmm.
We are live. All righty, hello everyone, I'm Elliot. I'm the Blockchain Program Director from the Den here. Sorry, I'm just getting text in the background. And today we are going to be talking about token curated registries. And we have with us today here our community manager, Zoe.
Hi guys, yeah, Zoe here, community manager of the Den. Welcome to the webinar. I want to give you a quick background about what we are going to talk about today. As Elliot said, we will talk about the token curated registry topic. Maybe for 1.5 hours. Feel free to ask questions in between, please. I will read them from the chat, but we will also have some time in the end to discuss other open questions. Quick background about the Ethereum platform, what it is. We had last week a webinar 101 on Ethereum, but for you to know that it's an open public blockchain. It's open to the world, so everyone can access and build programs on top of it, any kind of application. So you can run like financial applications, gambling applications, social networks, and so on. But since the whole blockchain technology or Ethereum is a quite new technology, I think it's really new to all of us to know what is the best use case, what is the best type of application on to build on Ethereum. A lot of MVPs are at the moment are built on Ethereum. But I think it's still, or it is actually a really still new stage for all of us. You can actually imagine it's like when the internet was built in 1980. I think it took us like around 10 years to really know how to use it in the best way, what type of applications we build, and so on. And we are now, in kind of the same stage. But the TCR is one of good use case, and we want to explain this to you today more in detail to actually accelerate a bit the whole journey, what to build, how to use blockchain, and what to build on Ethereum in the best way. And now I will give over to Elliot.
Perfect. Thank you so much, Zoe.
You're welcome.
Let's get right into this now. I first have to share the screen with you guys. Let's see here. Screen share. Okay. Alrighty. So we're going to be going over, just from a high level right now, we're going to go over what a token curated registry is, how it works, and kind of the inner mechanics of one. And then we're going to go into actually coding a token curated registry. So without further ado, let's get into it. Okay, so first off, what is a TCR? So a token curated registry is essentially just a registry that allows people to vote on things that they want to add into the registry. And so this is kind of very high level right now, and it doesn't really mean a lot. So let's go into it a little more and kind of unpack this. Okay, so within a token curated registry, there are actors, and there's 3 types of actors. One, we have candidates, and these are people who want to get listed on this registry. So if we have a registry that's in demand, people will essentially pay or put a deposit down in order to get their business listed on the registry. Curators, so that's one, candidates. Then we have curators. And these are people who vote with their tokens to list or not list a candidate on the registry. And curators take a very, very active hand in the things that can get listed on a TCR. And then we also have consumers. So consumers essentially passively view the list. They don't have to understand how to use blockchains, crypto. They don't have to understand anything, because you can just make a TCR that's all smart contract logic, and then the front end just pulls out data from the smart contract. And so when a user goes to the website, they're not even aware that they're looking at a token curated registry. They just think that they're looking at a site that hand selects businesses that have good products. So these are just kind of the 3 people that act in a token curated registry. And again, you shouldn't understand everything at this point. This is just part of this whole system. So let's keep on going. So let's look at the mechanics a little more. How does a token curated registry really work, and what are the kind of the data structures that are at play here? A token curated registry is really just a list. It's a glorified list. What you have is you just have the registry is just a list of businesses, of ICOs, of services, of products. Essentially, a TCR can be a list of anything. But what makes the TCR valuable and interesting is that this list has been curated carefully. So it's not just a list of random items or random businesses that aren't vetted. These are businesses and products that other people have used and curators have found valuable. So they voted to go and list this person on this registry. There's a little more that goes on there, but we're going to get into that later. Then we have tokens. So we have a list here of all these vetted businesses. But how do these businesses get added to the list? So what happens is a business will go and they buy tokens. So essentially, you'll start off with like a base ERC20 contract. And for those that don't know what ERC20 is, ERC20 is just a standard token contract on top of Ethereum. So you get your standard token contract, and what happens is businesses will come to this TCR, they'll buy tokens, and then they'll pay, or they'll put a deposit down of, let's say, 50,000 tokens in order to have their business reviewed to get put onto this registry. There's also voting mechanisms. So when a business goes and says, hey, I want to get listed onto, business says, I want to get listed on this registry, then the users, the curators, they now vote whether or not that business should be put on the registry. And so essentially, they act as, I guess, the majority of people that you would trust. So you say, okay, well, if these people own these tokens, we're going to say that they have some incentive to keep the list clean. So let's say we have a business A, and business A has they're a restaurant. And so this restaurant says, I want to get listed on this token curated registry. They buy, let's say, 10,000 tokens. They put them down as a deposit. And then the curators get to decide whether or not they want to list them. And your vote weight as a curator is equivalent to how many tokens you own. So let's say you're a curator and you have 50,000 tokens. And then there's another curator that has 60,000 tokens. Essentially, it doesn't really even matter which way the person with 50,000 tokens votes, because the 60,000 token person can override that vote. So let's say the 50,000 token person, they say, you know what, we don't want anyone to be able to, we don't like this business. So they vote no on the business. But the person with 60,000, they vote yes on the business. And that means that there's a total of 10,000 people or 10,000 votes for the business. So the business would get listed on the TCR. So as we kind of said, right, if you have, over 51%, or if you have 51% or more percent of the tokens, you can essentially vote in people. So let's say you're friends with a business and you own 51% of the tokens. Now this business isn't doing business honestly. It doesn't matter though, because you can just vote them in anyway, because you have more coins than anyone else. So boom, you can just add anyone in. But however, it doesn't really make a lot of sense to run a 51% attack unless you don't want an ROI on the tokens that you bought. So let's say you bought these tokens, right? You paid $1 per token. You have 100,000 tokens. So you're $100,000 invested into the tokens of this TCR. Well, now if you start listing businesses on your TCR, well, that aren't really credible, now the value of your tokens drop because your TCR will be less desirable for other businesses to get listed on on. And the only way that you make money as a curator is if other businesses are buying your tokens. And no one's going to buy tokens to take part in a registry that's crappy. So essentially, curators are incentivized to be honest because their token value rests on their ability to list good candidates. So one of the things about the TCR is if let's say a majority of users downvote your listing, then what happens is the people who downvoted you, they actually get to take a percentage of the deposit that you put up, which means that essentially there's an incentive to deny people to be on the TCR. However, you wouldn't want to just grief businesses and be unfair because not listing anyone gives you an empty list, which is not desirable to other businesses who want to bring more consumers to their platform. And then also it kind of cuts both ways. So you can be dishonest in not allowing someone to be listed, and you can be dishonest with allowing someone to be listed. And both cases are bad for you because if you list someone who is not credible, then your list has less credibility, and thus the tokens for this list are actually worth less. So Zoe, let's go to questions because I got really technical and really in depth there. Let's have a conversation about this.
But also like more actually competition you have is actually good also for this case, right?
Yes, essentially, like the more people you have who are in this registry, the more it's worth.
Yeah.
Because let's say we have like 20 of the best businesses in San Francisco all on this registry.
Yeah.
Well, now all other businesses are like, wait a second, there's all these consumers that are going to these businesses because they know that these guys are credible. Mm-hmm. So for us, it makes sense to, let's say, put up $20,000 in order to go get listed here. Get a return, and all these people will come to our business.
Yeah.
But what's also good is, let's say you're doing business in a shady way, in a shady manner. You wouldn't list your token here, or you wouldn't try and list your business here, because you'd put that deposit down of 100,000 tokens or 20,000 tokens, whatever it is, and people would go investigate and say, wait a second, this business isn't honest. And so that would mean that you would lose your deposit. So essentially, it solves kind of a problem that Yelp has, where it's like, there's nothing at stake on Yelp, right? Like, how much does it cost to get your business listed on Yelp?
Nothing.
Exactly, it's free.
Yeah.
So anyone can just kind of put anything on there, and you can kind of fake reviews and finesse things. Mm-hmm. But with a TCR, if your business isn't good, you wouldn't even ask to get it listed in the first place because you'd lose all your money.
Right. Yeah.
Yeah. Any other questions from the audience so far?
So far, not. Nothing in the chat yet.
Okay.
So we hope everything was clear from now.
Yes, and if anything is not clear, feel free to ask.
Yeah.
Feel free to ask. Okay, let's go back to this presentation here. Okay. Okay. So now let's kind of go into the differences of running a decentralized application, right, a smart contract, versus, let's say, running your application on a hosted computer, like let's say Amazon Web Services. So if we choose to host our application on top of, AWS, for example, if Amazon doesn't agree with what we're doing, or we violate their terms of service in any way, shape, or form, what can happen is our application can get taken offline. Or let's say, I guess a better use case would, or a better way to illustrate this concept would be, let's say we have a TCR for politicians in a very corrupt third world country. Now, the politicians would never let this kind of information get out on its own. They would never let someone host a website that held all this information about politicians, when it could threaten to expose the dirty politicians, right? Because you can't take down data on the blockchain. So what these politicians would do if it was just a regular web app, they could just ban the website or the domain and say, okay, you can't go to ismypoliticianhonest.com. But the great thing about smart contracts is they're immutable, which means that you can't really censor them. So because you're on top of a peer-to-peer network, it's really, really hard to just say, oh, we're going to just, shut this person's smart contract down. That exposes how dirty of a politician we are. Yeah, and you can't, right, it's immutable. You can't censor it. You can't just like go to all the Ethereum node operators and say, take your nodes offline, because there's, quite frankly, too many nodes distributed across such a large geographic area that it wouldn't be feasible to go and, visit all, let's say, 10,000 people who are running a node, figure out where they are, and, tell them to take their node down. Because you'd have to get them to comply. They'd be in different jurisdictions. It's essentially like you could never stop applications that are run on top of Ethereum. Right? You can't hack or corrupt the network. Right? And if you try and kind of cheat or put some fake transactions out and try and kind of skew something, people will be able to catch you pretty easily because everything is all in the open. And that kind of actually goes back to a point that we missed earlier on about the 51% attack. Well, I guess we kind of went over it, but it bears repeating. I'm not sure if I got it, if I explained it correctly. So essentially, if you have a TCR, right, it's essentially the majority who votes on a candidate or like a business getting listed wins. So essentially, if you own 51% of the tokens, you can skew things. But the problem with getting people in who shouldn't be on the TCR is it devalues your listing and thus devalues your tokens. So it doesn't really make a lot of sense to do this. Okay, so that's all for kind of the high level of. Let's go ahead over to Remix now, and let's go ahead and start coding this. So we're going to start very, very simple. We're just going to just make a we're going to Remix. Remix should be working. Okay, yeah, we're good. Let's make a new file here. TCR.sol. Perfect. So we're going to specify the version pragma here. 0.5. Let's say version 1. And contract is going to be named token curated registry. Okay, so now we have to implement a few things before we can even think about these tokens. So let's see here. So before we can even think about the registry and allowing users to register or add items to this registry, we're going to first have to define a few things. So number one, we're going to have to define a struct, and the struct is going to tell us what's going to be contained within the struct. This is going to be candidate info, and inside the candidate information, we're going to specify. We're going to specify. Let's see, the address of the owner. So we're going to say, who this candidate is. We're going to specify. Let's see. We're going to say the name of business. We're going to have another string to say business address, so we know where to find them on a map. And we're going to have we need even 256 bits for that. That's wasteful. Let's just do UNT 40. That's 5 bytes. That's plenty. UNT 40 phone number. Okay. So we have essentially the struct for candidates. So if you want to get listed, you're going to make a new instance of this. But before you can even make a new candidate, you have to be able to buy tokens. So we're going to make a mapping. We're going to map UINT 256. So we're just going to map. Oh no, sorry. We're going to map an address to a number. So this essentially is everyone's balance in tokens. And then we're going to say in the constructor, we're going to say balance of, we're going to say address 0, so no one really controls this. Balance of address 0 equals, let's say, yeah, 1,000,000 tokens. And we also need to store who the owner of this contract is, so that they can authorize transfers of tokens. Let's say if we want to do an airdrop. Okay. Our code breathe here. Okay. So we're also going to specify here owner equals message.sender. And now we're going to allow people to buy tokens in order to list themselves on this platform. So let's actually specify a price here. So let's say cost, listing cost. And we're also going to say we need to have a number for not only listing, but we need a number to for the price. So token price. We'll just go ahead and put underscores under these just to note that they're not the global values. And we'll say right here, we'll say, so we'll make a public number, listing cost, and we'll make another number. It's a global, essentially, token price. Okay, so now in the constructor, we're going to say listing cost is equal to underscore listing cost, and token price equals underscore token price. So when we initialize this contract, we let the contract know essentially how much a token costs, and we let the contract know how many tokens you need to get listed. So we'll revisit this later. So then we're going to say function buy tokens, and it takes no parameters. It's a public function, it's payable because you can send it to Ether. And what we do right here is, I guess we just check that you didn't send no balance. So just make sure that message.value is greater than 0. Otherwise, you say error. You must send from Ether. Okay. And let's also make a require statement here because we want to make sure. Alrighty. So we want to make sure that also actually that message value is greater than or equal to the token price. So the error should be error. You must send enough Ether to buy a single token. So that just checks to make sure you didn't just send under the threshold of a token value and then you don't get any tokens in return. And we're also going to require that the balance of address number 0, where we loaded all the tokens up initially, is greater than or equal to the message.value. So the amount of money you sent in divided by the token price. So we want to make sure that there's actually enough tokens to sell you. So error, not enough tokens for sale. Okay, perfect. So now that we know that we have enough tokens here, we're going to make a little internal function here. So this is just a function that no one else can call but the contract. And it's going to say address to address sender and UNT256 amount. And it's an internal function, meaning no one else from the outside can call it. And what we're going to do here is we're going to say balance of address 2 minus equals amount, because before we called this function, well, I guess we'll double check here. So we're going to require that balance of the person we're sending it to is greater than or equal to the amount they're trying to send. Otherwise, error, you don't have enough tokens for that. Okay, now we subtract the tokens from the person we're sending it from, and we add the tokens to the person that we're sending them to. So we say sender, oh no, so the person we're sending it to gets the tokens, and the person we're sending it from gets tokens subtracted. So that should work right there. And what we're going to say here, we're going to say underscore transfer. We're going to transfer it the message dot sender. The sender is address 0, and the amount is message dot value divided by token price. Okay. So now we have the basics of letting someone buy the tokens. Mm-hmm. And now that you can buy tokens, yeah, I guess we'll make another transfer function. Actually, we can just, oh, yeah, okay, so we'll make another function for transfer. Transfer tokens, address to UNT256 amount, public. You guys, any questions, let me know. Questions, all questions. So require that balance of message.sender is greater than or equal to the amount that you're trying to send. Error, error, not enough tokens to do that. Okay.
Elliot, one question from earlier. Katie was asking if candidates know how many tokens each voter has, so the potential influence of each voter.
Yeah, so we can, well, what we can do is we can like make those, let me answer this. So we can make variables private in Solidity. The only problem with this is that even if you have private variables, you can actually still dump the memory or the storage from the smart contract. So we actually can't really hide the amount of tokens that somebody has. Because if there's a sophisticated enough attacker or sophisticated enough individual or corporation, they can go and dump all the memory from the smart contract and they can go back and reverse engineer and look at all the transactions that occurred and see which ones made the changes to the storage. So you really can't hide who voted for what, but there are there are cryptocurrencies that are kind of devoted to private smart contracts, and there's also layer 2 solutions on top of Ethereum. And with those solutions, you can actually make your contract private in the first place, which means that no one can know who voted for what business. So you can have anonymous voting. But in order to do that, that's a lot of extra work. And you have to integrate with some other solution. It's not just boom, make a Solidity smart contract and you're going.
Okay, interesting. I hope this answers Katie's question. Another question from Tao, since we're here. What happens if there's a failure after Ether deducted but before tokens are transferred?
Okay, let's go and check this here.
Mm-hmm.
Let's go look at the entire screen. Okay, here we go. Okay, so what was the question again?
What happens if there's a failure after Ether deducted but before tokens are transferred?
Okay, so that's not possible, because if there is a failure, all changes made will be reverted. So let's say we start off on this line, right? So it's like, okay, we make sure that you have enough Ether that you sent in order to buy a token. But then we realize that the person that you're buying from has no more Ether to sell, right? Well, what would that practically do? What would happen is, let's say there's not enough tokens left to sell. What happens there is it reverts, and that means that your Ether gets refunded essentially. Now you pay a small fee for the gas, so you had to pay for this computation and this computation to happen, and the miners to compute that. But after they computed that, they realized that your transaction was invalid, and so you actually don't have to pay for anything that happens after, or you don't have to pay for anything afterwards, and your Ether that you sent in gets refunded. So that's how it would work. It can't happen that, it just executes halfway and stops. And the VM is actually built in a way that if you get halfway through, like let's say we get to here, we get to this step right here, this last step where it's about to subtract your balance, but then it turns out there's not enough gas, there's not enough, you didn't pay enough for computational units, which is the gas, to actually execute the contract. What happens at that point is the whole transaction reverts, meaning you get all your Ether back that you sent, but you lose your gas. So you lose the money that you paid for the computing. But what's great is that it didn't execute halfway, because you don't want halfway or hanging execution, because that can just introduce a lot of bad things and bad bugs that would be horribly hard to account for.
So Tara asked again, so what's actually or what defines the start or the stop of the full transaction?
Okay, so the EVM, when it starts a transaction, it loads up like the data of the person who called the VM. So it loads up all the call data. It figures out what function you want to enter, and then it has this thing called like the remaining gas and the current program execution pointer. So the execution pointer points to every single opcode that it has to do, and it executes every single opcode. And what happens is if it tries to go to the next opcode, before it goes and executes another opcode, anytime it does an opcode or does a computation, it checks to see if you have enough remaining gas to perform that computation. If you don't have enough gas to perform that computation, it stops execution right there and undoes all the state changes. So it's just really it's a very well designed system, because if you don't have this, essentially if you don't have this, then people could just kind of have a transaction that hangs in the middle of execution. Did that answer your question?
Okay. I hope so. If other questions come up, I will let you know.
Perfect. Okay, so now we're gonna, so now we made sure that you have enough money to send tokens. So now we're gonna just call transfer to, and then there's a second parameter, yeah.
Yeah, Elliot, before we go ahead, there came another question to this topic. So offline, okay, that's fine too. Yeah, maybe Taho, it will be a longer discussion. So Taho just said he can talk about this offline.
Yeah, perfect.
Go ahead, Quim.
Okay, so now we've built out a function to buy tokens. We built out a function to transfer the tokens. Now let's make, now let's start like actually building out the TCR part of this whole thing. So what we're gonna do here, let's make this more visible. So what we're gonna do, we're gonna say function get listed. So in order to list your business, there's gonna be a few requirements, but we're gonna get into that. So let's go to the top here. We need to have all these parameters passed in as arguments to the function so that we can actually get people listed here. Okay, so all right, we got a lot of parameters here. Let's just kind of go down like this. And so this is the function to get listed. Public. Oh, whoopsie, that's already declared variable. Oh, string. Okay, in the newer version of Solidity, if it's not on the stack, you have to specify the area of the variable. So in this case, it's strings and bytes are in memory. Okay, so all right, let's go here. Okay, so now what we're going to do, before we actually can even start thinking about listing this, what we need to do is we need to make sure we have a data structure to keep track of who is already listed from their address, has already listed a candidate. So we say, we map an address to a Boolean, we say been listed, and we have a mapping from a number. Well, actually, you know what we're going to do? We're going to make an array of candidates. We're going to say candidate info. It's going to be a static array. We're only going to allow for 10 people to get listed on here. And we're going to say public all candidates. Okay, great. So now we're also going to put a Boolean in this struct. We're going to say is listed because we need to keep track of whether this struct has been listed before. So now that we got all this down, let's go back to this get listed function. So first off, remember what the initial requirement was to make a TCR? We essentially have to check that the balance of the person who's calling is equal to our cost to get listed. And we specified that up here. We said that was the listing cost. So make sure they actually send more than or equal to the amount of listing cost. And otherwise you say error, not enough tokens to get listed. Okay, perfect. And what else do we have to check? We need to get a free listing index in our array of all of our candidates. So we're going to say here, we're going to make a function called function get free listing index public view turns uint. That doesn't need to be 256, but whatever. And what we're going to do in here, so we say uint 8, I equals 0, I is less than 10, I plus plus. We're going to go through our whole array of all of our candidates and check for a free index. And we say if, what's it called, all candidates, if we find a free listing in here, because our TCR is limited, we're going to say for simplicity's sake, there can only be 10 people inside this registry at any given time. If it equals false, so if this has not been listed already, what we're going to do is we're going to go ahead and return I, because that means we found a valid index. So let's see what it says here. Oh, right. Okay. So we just go from 0 to 10, and we find a free index. And now what happens if we get to the end of the list and we can't find a free index, what we're going to do is we're going to revert, because error, no, because there's no free listing. We say uint 256 free index equals get free listing index. Here is no free listing index. The function is just going to revert. There's no to worry about handling errors any farther down, because we already know that up to this point everything is error free. We could do some error checking to see that we don't need the address of the owner, because the address of the owner is the person who's sending the message. Now what we're going to do is we're going to say, if you want to get listed, now what happens is we're going to make another mapping where we store all the people who have already deposited tokens. Okay, I can't get the mouse to cooperate here. So what we're going to say is, Windows. So it's not the balance of, so deposited balance right here. Oh man. Okay.
Quick question from the side. What is Tao asked, like, what if a candidate is already listed? So duplicated listing.
True. So let's see here. So if you already, we're gonna say if you're from the same.
And sorry, but Elliot, there's all candidates. There's a misspelling, I think.
Where?
Oh, candidates in general. It says candidates.
Oh, candidates. Yeah, that is correct. So change that up here.
Candidate. No, it's with.
Huh?
Candidate. I think you're missing the D.
Yes. Yeah, we're adding that in right now. Candidates.
Perfect. Yeah.
And there we go. All right. So that should take care of that. Oh, no. Okay, that works. Okay, so if the owner right here, if we've seen the owner previously, then we're gonna then we're just going to go ahead and revert. Error, you single address cannot own or cannot list more than one candidate. Okay. And I guess we're going to need to do this in a separate loop. So we're going to have to loop over everything and make sure that we haven't seen this person before because that would not be good for us. Okay. Expected a closing parenthesis. Okay, there we go. That's good. Okay, so we go through, we make sure that this person has not been listed in the registry before. And I guess there's a cleaner way to do it with a mapping, but it doesn't make sense to add another data structure. They'll get cleaned it up later. So we have the free index, and now we say all candidates at free index dot owner equals message dot sender. So now we're just going to initialize all these struct values here. And let's see here. Dot business name equals business name. Let's see here. Okay, business address equals business address. And let's see what else. Phone number is equal to phone number. And we also are going to say that it is listed so that someone can't use this index again. And we're going to need to subtract the amount of tokens that they own. So we're going to say balance of message.sender minus equals listing cost and the positive balance of message.sender plus equals listing cost. Okay. So essentially now they have the positive balance, but if you go look up here from before, we're not allowed to transfer deposited balance. We can only transfer, we are only allowed to transfer tokens that are not deposited. So essentially, so when you create the listing, what happens is we go through to get listed. We make sure that there's a free index. Then we say, okay, we take away the amount of tokens you have from your balance. Then we add the amount of tokens that you use to buy this listing. We add it to your deposited balance. And let's see what else. Yeah, so that's pretty much good for right now. And now let's say function remove listing. And so it's public, anyone can call it. And essentially what this is going to do, you know what I'm going to do, because I think loops are really bad practice in Solidity. We're going to make another mapping at the top up here. And we're going to use this mapping to map an address to an index. So uint8 public index of listing. So if you successfully list, we store where you listed. So we say index of listing message dot sender equals free index. Oh, whoopsie. We'll just cast it down. Okay, so we're going to cast UN256 down to UN8, but it doesn't matter because I could never be over 10 in the previous function. So I guess we can make it UN8 to make it cheaper. Plus data as a whole. And right here, we're not going to say it's a UN256, we'll just say it's a UN8. And you guys, please let me know if I'm going, too fast or stuff doesn't make sense. Okay, remove listing. So now we say we require first that the deposited balance of this person is greater than or is equal to deposit, where is that? The listing cost. So we just make sure that you've already actually listed some tokens and you have something that you can free up. So if that is true, what we'll do is we'll say, if you don't, we'll just say error, you must have a listing. Okay. Now we've got your balance, or we've who you are. So now we're just going to delete. That's the purpose. We're going to say you went 8 equals. We had a mapping before. Index of listing. Message index of listing. What we're going to do is we're going to say delete. What is that? Candidate. All candidates at that index. So essentially, just zeroes out that storage. It doesn't actually really delete storage and solidity. So we're just zeroing it all out. That sets all values to 0. Now, after we set all, we need to type your deposit, and we need to add money into your actual balance because you get your money back from listing. So we just have to reverse the order of operations here. So we just give you your money back, and then we say we subtract that money from your deposited balance. And now this is a very, very simple, very simplified TCR. There's a ton more we could do with it. For example, in a real TCR, there's actually a voting period. And so in this, we would say, we could add a little field that says, time that someone tried to list. And then we could have, while there's, let's say for the next 2 weeks, people are allowed to go and contest the listing. And then if the listing isn't contested or there's no net negative for this candidate, then we say, okay, this is a valid listing. So let's go ahead and run this right now, just this in this very simplified. So okay, let's make this a little bit bigger here. Oh boy. Okay, there we go. So listing cost, we're gonna say it's 1,000 way or 1,000. It's 1,000 tokens to get listed, and we're gonna say that it costs 1,000 way, 10,000 way, 100,000 way, 1,000,000 way, 10 million, 100 million, a billion. Yeah, that's a pretty cheap price per token. Okay, so we're going to deploy this contract here, and it's on. Oh no, we don't want to be on ring B. It's not right. Let's just do it locally on the JVM. Or not JVM, JavaScript VM, same thing. So we're going to say 1,000 tokens to get listed. Okay, great. So now we have our little token curated registry right here. Let's see here. So let's look at our current balance here. Let's copy this. Yeah. Copy this address right here. Let's get our balance. And our balance is 0, so we have no tokens. So let's go up here and let's say, let's buy an ether worth of tokens. I'm sure that'll be enough tokens for us to get listed. 1 whole ether, and let's send that to buy tokens. Okay, so we did that. Now let's look at our balance. Oh. Let's see what went wrong here.
Here was a comment from Taho for the delete listing function. Shouldn't it be like require and then deposit balance message sender bigger equal listing cost in the delete listing function? I'm not sure which line it was.
Right here on line 78.
Let's see. Yeah. Require deposited balance message sender bigger equal listing cost. What do you have?
No, because you could never have greater than the listing cost. Because right here it just says you get added. Listing cost gets added to your deposited balance. So you could never have a number in here that's not either 0 or listing cost.
Okay.
So this works out just fine.
Mm-hmm.
Okay, and we didn't actually make enough tokens here, so let's cut back on how many 0.1 ether, and let's call it by tokens. No, okay, that's too much. Okay, let's go with 0.0001 ether, and let's buy tokens. Okay, there we go. So now let's get our balance. Plenty of tokens, and let's go ahead and list. Let's get listed. Okay, so let's. A business name is Den. Address is let's just say it's 100 Warm Springs Boulevard. Phone number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, very original here. And let's go ahead and transact here. Let's see what it tells us. Oh, perfect. Let's see what the gas cost was there. Yeah, it took up quite a lot of gas, but I think that's acceptable given that this is kind of a high value contract to interact with. So it makes sense for someone to eat the cost of the gas in order to execute that. And obviously we could streamline this in the future, right? We could take out one of those loops right here because this is kind of inefficient. We could have just referenced it in the mapping and make sure that he didn't have any deposited balance. Yeah, that's actually a way better check. So let's say if, okay, so we don't even need to iterate through all these right here, so we can actually save on gas. Okay, so if deposited balance is equal to listing cost, we know there's a problem. We're going to take that out of the loop there because that's going to save us some gas. And we're going to just delete this loop here. Shouldn't really save us that much money, but reading from storage when we're actually using gas is kind of inefficient. So we'll just add this here as another little error check here. Make sure you have enough tokens to get listed, and we're going to make sure that we can just pack that all into one required statement right there. Okay. Okay, so then we're going to require that that you don't have the balance of the listing cost. Because if you did, that means you already got listed, and we don't really want that. Okay, so now let's go back here. Let's get a free listing index. Oh, it doesn't want to cooperate. Okay, let's see here. Well, I guess that's not really meant to be called from outside. We're not going to worry about that right now. Oh, right, because that's already, right, we're not allowed to call that one again. So now we already have a person, they're allowed to go ahead and list themselves. So let's just make a quick getter function so we can look inside of our contract and see that we actually got a valid listing. So get listing, uint8 index, public view returns. Okay, what do we need here? In our struct, we have these 5 fields. So we're just going to copy them from here. We're going to go down here. We're going to paste those in. And once I'm going to paste those in. No, didn't copy them. Okay. Control C. That should work. Okay, that's annoying. All right. We're going to copy them. And then we're going to paste them down here. Okay, that doesn't work. Whatever. So we have the owner, business name, business address. Put that for right now. Address of the owner. String memory, business name. String memory, business address. uint 40, phone number. Okay, that's perfect. And let's get this started. Okay. So we're going to require, first off, that this listing index is actually in use. So we're going to say all candidates at list index dot is listed equals true. Otherwise, we say error, nothing listed at this index. Okay. Now we make sure that something's listed here. So now we say return, and now we're going to return all the values. So we're going to return all candidates at list index, and we're going to get the owner. And so we're going to go through this and do this for every single item that we have here. Is everyone with me so far? Okay, I'm assuming everyone's with us. We'll keep going here. So now we're going to get the business address, and we're going to do the phone number. And now that should be everything we need So we don't need to specify that name. Okay, so that should work. And let's go ahead and redeploy this right here. And actually, let's just go give it a billion tokens so it can't break. That's a really annoying error to get. Seems that our community taken off, or the internet just bad. Okay, what are we looking for? Oh yeah, so let's just say right here that just add a bunch more tokens. Yeah, perfect. So we have infinite amount of tokens. So it doesn't really matter. Costs, you know, a million or whatever, 100,000 tokens to get listed. Costs a lot of tokens, or tokens cost, you know, let's say a billion way or somewhere around there. Okay, great. So now we have this TCR here. And say, Ben.
Hello, Elliot, sorry, I was offline for a minute. I think you're not sharing the screen anymore.
Say that again. I'm not sharing screen.
Yeah, we see you.
Oh, okay. Well, let's go ahead and share the screen again. I think my internet is having problems.
Yeah, mine's somehow too. But great, yeah, now it's back. I see it.
Okay.
You know.
Okay, you guys, let us know in the chat if anything was anything went wrong here. Okay, let's try and list this thing here. Oh, and look at that. It says we're getting an error, not enough tokens to get listed. So we need to go ahead and buy some tokens. So let's go ahead and load up an ETH here. And let's click on the buy tokens. And then let's go ahead and get our token address. And let's get our balance. And it looks like we got plenty of tokens here. So now when we try to transact here, let's kind of sit here and go through this loop for a second. And then boom, we're in. So I'm assuming our listing index is going to start off at 0 because it's going to find us. I'm just going to say, oh, okay, well, your index 0 is free. So let's get the listing from that index, and boom, we click on that. It shows my address as the owner. It shows the business name is the Den. It says, you know, we're in Fremont, and the number is correct. And I intentionally made a uint 40 with 5 bytes so that you couldn't, you know, have an insanely long phone number. So I think that really wraps up this very technical walkthrough of a TCR. If you guys have any questions, let me know. Oh,
yeah, we actually have this some more questions. So it was also to the candidate listing. What if candidate is being listed by another party, or like the service? The address of the lister is not the identity of the candidate.
Okay, yeah, so the thing is, we're not checking for duplicate business names, because the problem with that is, you know, anyone could just say, oh, you know, let's say I want to double list the Den. I say the Den on one listing, and then on another listing I say the Den, and I just do a lowercase e. And to do a lot of string compare operations in Solidity is very expensive. So really to do any sort of like meta string comparison is expensive. So I would just say, you know, let's make our life easier and not consider that case, and just say that it doesn't really make sense economically for someone to want to list the same business twice, because to list it once is already good enough. You're on the listing. But to list it twice, it means you're there twice, but once you're there once, you already got all the publicity. So you don't really get any added benefit from listing yourself twice. So it doesn't really make sense to go and, you know, try and figure out all the ways people can tweak names and, you know, figure out if there's substrings within these things, because it's like your return will be nothing and you're not really gaming the system. So it doesn't really make sense for me to spend my time here. to try and catch you, doing something like that, because it doesn't really harm anyone. Any other questions?
Okay. Yeah. One more from Tahoe. This is why an identity function is needed. What about sock puppets, etc.? Sock puppets. Sorry.
Oh, sock puppets for people listing multiple businesses, or sock puppets for people who are the curators? Because in either case, it's a different kind of dilemma.
Okay. Let's see what he means.
Yep.
Yeah. Just reply to this.
What did he say?
He didn't reply yet.
Ah, okay.
But the question again, this is why an identity function is needed. What about?
Yeah, the problem is it's really hard to do identity when the only thing that you have for identity is message.sender, right? The only way that I can know who you are when you call a contract is if I just keep track of who you are and all the people who have called my contract. So we accounted for one person or one address trying to list two businesses under the same address, right? Because we made a mapping that says, has this person already been listed? So we kept track of that. But, for like, let's say if one person owns two businesses and one person makes a listing with one of their addresses and they make another address and make listings, there's no real way to account for that currently, unless you want to start really, really, really heavily permissioning the contract. At which point, if you really permission the contract and make it so that no one can really just enter in and partake in the system, is it really decentralized anymore? And if it's not really decentralized, why not just go make a traditional web application? Because then you don't have to worry about things like security, or you do have to worry about security, but it's a lot easier and it's a lot like you can patch things. Whereas with Solidity, going and doing an upgrade on a smart contract is just horrible. So, or it's just really not possible in most cases. So you kind of have to weigh the trade-offs of the application and like the system you're developing on top of. And I also forgot to add a withdraw function here. So we're gonna make a quick withdraw function that lets the owner withdraw all funds. And it's a public function.
You want to share the screen again, or?
Yeah, let me show the screen here. Here we go. Okay. If you want to withdraw the funds, we're just going to require message.sender equals owner. And then we're going to say message.sender.transfer address this dot balance. Okay. So we take the current contract and we take all the funds out of it. We cast the pointer to an address. We get its balance and we send all the balance to the owner of the contract. So this is just a simple function so that once you have built out a successful TCR, you get to kind of reap the rewards of that, and you get to make some money off of it if it is successful. Any other questions from the audience? Let's see here.
We had one in the beginning. Tahoe said we can discuss this offline because it was more detailed question again. Did I read it and you decide if you want to answer it right now or?
Code is not being. This is why an identity function is needed. Yeah. So he's saying either problem exists, of course, right? Because you really can't. Yeah. I mean, it's really, really hard for you to do identity in a decentralized. There's a lot in a decentralized blockchain, decentralized environment. So yeah, I mean, it's really, we can't really sit here and say, oh, well, we can't do that, so therefore it doesn't really work. It's just we can't do it currently, but in the future, I think it'll definitely be available, and I think there's a lot of people who are very smart who are working on solving this problem. So this problem will be solved at some point, but who knows when. Yeah. So I think that's going to wrap everything up here for tonight. I want to thank everyone for asking all these interesting questions and getting all the spelling proper for my variables. Yeah, thank you guys for coming out. The Den offers a course where we go a lot more in depth into smart contracts. So it's a 14-week course. It's 1 day on the weekend. You can actually take it online, and it just takes you from like zero, so understanding nothing about blockchain, to mastering all the core fundamental blockchain concepts. And then it goes and shows you how to go build out applications on top of Ethereum. And we also go show you how do you secure your application, because when you deploy your code, the code stays there. And unless you make it an upgradable pattern, you can't upgrade the contract afterwards. So if there's a security hole, your money can be gone. So we walk you through all these things about how to not do that and how to make smart contracts that are secure. And if you're interested, just go to theden.io/apply. Thank you for your time here. And Zoe, any last words?
No, just the last question from Kathy again. Do you have an example? Do we have examples for TCR?
Oh, yeah. So currently, like one of the bigger TCRs is AdChain. And so what they do is they list like advertisers, they list websites that actually have real traffic. So let's say like you're an advertiser and you want to know like, oh, is this place, is this website that I'm about to spend, $1,000 on to put a little, ad on the side of it, is this a credible website? And so what they do is there's a TCR for these websites that offer to, host your ads. So you can tell essentially by this TCR, you're like, oh, is this website credible, right? Let's say the New York Times. They say we have 20 million unique impressions per day. And let's say I'm a New York Times insider. I know, okay, this is true. And I go and I audit them and I go look at all the resources on the web and I see, okay, yeah, these guys actually get this amount of traffic. Then I, as a curator, would vote them in. I'd say the New York Times is a legitimate place to advertise with, so feel free to advertise there. But if they're not legitimate, then what I do is I would downvote them and they wouldn't get listed on the TCR, because people realize, oh, wait a second, they're kind of fudging their numbers, they're not really doing business on the up and up. So that's just kind of one example where it's being used right now. And I believe there's other TCRs that are being used for restaurants. So it's like Yelp, but a TCR, which is a really great concept because, right, there's the kind of thing where you have to pay some money in order to get listed, which means that you have some sort of confidence that, yeah, my food's good, otherwise you wouldn't list on it in the first place.
Great. Cool. I think this answered the question. And yeah.
And also, we also have, let's see here. We also have a Telegram. So if you have any questions that are lingering, even after this little code walkthrough, you can go to our Telegram and ask us a question there, t.me//dennexus and twitter.com/dennexus. Yeah, so definitely ask us a question here if you want any more in-depth knowledge in any of the things that we asked here. Yeah, thank you so much, guys.
Great. Thank you, Elliot, and thank you everyone for participating.
Thank you, Zoe. Bye-bye.
Bye.